Welcome.
Thank you very much. Hi, good afternoon. Yeah, this is Hakim. I'm the chief researcher of the AI Research Center in TII. So TII is part of the, just quickly for you to understand a little bit the context in which we are evolving. So TII is part of the ATRC. I'm coming from Abu Dhabi, the United Arab Emirates. TII is the research arm of the ATRC. We are a government entity funded by the government of Abu Dhabi. Together with us, we work with Aspire, that is our program management entity, and we have Venture One that is working mainly on the commercialization of our technologies. TII is not just working on AI. We have a lot of work around different technology domains, including quantum, robotic, directed energy, security and cryptography, space, and propulsion, just to mention a few. So today I came to discuss a little bit about the Falcon large language model and the work we are doing in this field of building these models. I was here last year, but I was more talking around the fundamental aspects of large language models. This year I thought I would more take you through the journey that we have taken to build these models, but also the point where we reached, that is actually moving towards solving real problems with this AI, where I believe the community is a little bit struggling these days. So we aim, I would say, as everyone, to build the most interesting large language models. We are building and releasing at least 2 series of models every year. The latest series that we have released was just in May, last May, and I will come to that. The reason is basically we see today that there is a sort of polarization of the AI, where we see on one hand the US that is working extremely hard to keep the momentum, and then we have China that is also growing when it comes to this AI. I think the UAE and Abu Dhabi is trying to be in the middle and serve as a sort of support for the community when it comes to open source. So we are open sourcing all our language models so far, starting from the 1st generation until the 3rd generation that we have. So this is a bit of sort of a timeline of the models that we have released. We started back in 2023, 2 years back, releasing a 40 billion parameter model that was competing with most of the models that we have all around the world. Then a few months later, we open sourced the 180B. That was the 1st generation. 2024, we went to open source the Falcon 2. So we have learned a lot actually from the initial generation of our language models, and we understood actually that the models, they shouldn't be big, right? Having the infrastructure that would support those models is an extremely big challenge. So we started building smaller models. This is where we went to Falcon 2. It was an 11 billion parameter model, but we didn't only do that. So we also started working on the multimodality, where we have actually added the vision layer to this model. We continued working, and we started again sort of compressing high performance into smaller models. This is where we went to the 3rd generation of our models back in last December of the last year, where we had the Falcon 3 with different sizes, but with performance that was outperforming all the models that we have there. But then we started reaching actually a sort of plateau when it comes to data. We started using all the data that we had. So we thought of also going into another aspect of these models to improve these things. So this is where we actually started working on the architecture. The question was, what happens if we actually embed updates or more, let's say, innovations inside the architecture? This is where we started actually working on the combination of the transformer and the state space modeling inside the same model. So I think everybody is familiar with the Mamba large language models or the Mamba architecture. So we have been working on the Mamba. We built a model that was extremely good in Mamba. But the question was, what happens if we combine at the architectural layer the 2 kind of tools like modeling, the transformer, and the Mamba. This is what happened, actually. This is what we have released last May. So if we released the Falcon H1, so we have different sizes again, 34, 7 billion, 3 billion, 1 billion, and 500 million parameter models. The nice thing with these models is actually, as expected, in terms of performance, we started reaching extremely good performance, and I will show that in few seconds. So that was the last model that we have released back in May. So we released the transformer plus the Mamba kind of architecture. We released the Arabic model, and we released also the bitnet that is the most powerful bitnet in the open source community. And on the bitnet side, again, we are working on the sustainability of this AI. So we were able to run these models on infrastructure that is 10 times less than the usual architecture or the usual infrastructure that we use. That was a big achievement at the time. So these are the latest models, as I was saying. But if I go to the performance, this is the performance of the H1, and I believe it's interesting to look into this thing. So you have this figure that is representing actually the performance of the H1 at different sizes, and you have the performance. You can see that although we are reaching sort of, let's say, a plateau again in terms of data, we have consumed all the data to run or to train our models. There is still a hope when we go to working on the architecture. So probably the transformer is saturated, but if we look into other ways of representing and capturing this knowledge, probably we will reach to better performance as we move forward. So I know that we are more interested nowadays in agents, for example. We are more interested in this kind of, I would say, software engineering kind of problems, but we still have challenges to solve when it comes to the underlying foundation that is the large language models. So we have been testing all the models on different benchmarks, and you can see in almost all the time the H1, the hybrid architecture, is always performing better than any other architecture or any other model in equivalent sizes that you have. We have actually reached the point, if you see at the end, we are even, our 34 billion parameter model is actually performing better than the 70 billion parameter model. So the model is capable of performing better than the models that are twice the size of that model. In terms of tasks, LLMs in general, they can do a lot of tasks. All the green ones are supported by the current LLMs that we have. We do not work on the generation part, on the multimodal generation. We focus more on the multimodal understanding, but the generation is hopefully coming soon in the very coming generation. And just to show you the work that we do usually, and this is, I'm taking the example of the Falcon 3. So we do pre-training in general, but then we have a lot of other tasks, processes that we apply on the models to be able to reach the performance that we have. We work on distillation, we work on the SFT, we work on the upscaling also. The 10 billion parameter model that we have is an upscaled model from the 7B parameter models. Then we go to quantization, and this is where we want to bring these models to run on small devices. Small devices, we go until having sort of almost IoT kind of things, right? So, and I think I have an example later on where we are capable of running this model on just surveillance camera, right? So this way we control actually the stream that is analyzed, and we don't need to go we don't need to share the stream all the time. That goes back to a central unit. So most of the people, they know Falcon when it comes to text, right? So I wanted to show a few examples on things that can be done on data that is not necessarily text, right? So this is the VLM that we have, and I'm just giving you some performances compared to the different models. So these things can be found easily. So we do text, but we do also other tasks when it comes to the vision. So the OCR, for example, everybody is talking about OCR. So the model, the Falcon Vision, is capable of understanding images, scans of images, and extracting the text, exporting the text in different format. Eventually, if you want to discuss also with the text that is extracted, it's extremely powerful, and it can be used to build different applications. So for those who think that this case is not complicated enough, so we have the next case where actually you can get an understanding of documents that are, in my opinion, it's an extremely complicated case to get this data or to get content from this one. So the Falcon, again, is capable of understanding things from the scanned newspapers and is capable of answering questions when it comes to the user inputs. Falcon also does charts understanding. It's extremely powerful when it comes to chart. You can understand the chart, explain the chart, but you can also, it is capable of generating charts when you want, for example, to reformat or change the chart. Spatial understanding, I think I can share the slides for those who want to sort of look into the case in much more details. But these are questions in which all the computer vision tools, not just VLMs, they struggle most of the time, right? So asking questions like, what is behind the elephants on the right side of the image? Of course, for us, it's a pretty straightforward question. But when it comes to the computer to understand these kind of things, it needs a lot of training. And this is where Falcon actually is doing extremely well. Falcon understands images, but it understands also video, right? So these are benchmarks on the video part of the Falcon. So we have specific model for understanding videos. And again, when we talk to people, like they understand that, or at least they interpret that what is video at the end of the day? It's just a sequence of images, right? So, but video is much more complicated, right? Understanding the transition of scenes and these kind of things is part of how we analyze and understand the video, and this is what we integrate inside that. So the system or the model is capable of understanding the sequences and the way the videos are running, and at any time of the video, people can ask questions on the video and get the answers at the end of the day. We have very complex patterns that need to be identified. This is one of the most complex cases when it comes to the vision and the video. And again, we were able to train a model or an LLM, a VLM, to understand and to interpret these kind of things. It does also some planning. So we give videos and we ask the system to plan some tasks, some actions. The system, the Falcon, is capable of proposing different aspects. And we have embedded sort of reasoning, and we are giving that reasoning as an output of the model just to make sure that the user is capable of understanding or following the logic, the reasoning that is done by the model. Last but not least, so we have I couldn't build better slides than these ones for the audio, but we have part of the model that is capable of understanding and analyzing the audio. And at least on the benchmark side, it's one of the best models that we have out there. So these are the benchmarks. So we have audio understanding, and where we have the AAR benchmark or bench foundation. Again, what we are trying to do here is we have built capabilities and we have built tools that are capable of understanding not only text, but to reinforce the capability of merging or mixing different modalities and be able to understand these things. Some examples of applications. I will just give you three of them. So here is that's what I said before. We have been working a lot to bring the infrastructure footprint, I would say, for these models to run on smaller devices. So the Falcon 3 Vision, for example, the VLM, is capable of running on an iPhone. So we don't do much modifications, but because of the different architectural improvements that we have done, the model is capable of running and handling videos directly on the mobile phone, right? So the video is a little bit long, but the idea is that we are asking questions on the mobile directly, offline, without the network on the video, and getting answers on that. Phoenix security, or the Falcon security as we call it. So we are working currently on specializing these models, and I think this is what all the folks in the area of building models is focusing on, how to specialize these models. So here we have a good progress on making Falcon capable of understanding or extracting vulnerabilities in software. And we are not handling the source code, but we are handling binaries when it comes to software. And we are capable of identifying few vulnerabilities. We are building on top of that, actually, to make it more powerful. The last example is Tactica. So Tactica is here, actually. We are gathering different sources of information, including satellite images, for example. We are reasoning on top of that, and we are providing recommendations, actions to take for the operators to be able to understand and build alarms very quickly. What's next? So again, most of the people nowadays, they talk about agents more than they talk about LLMs. That is a fair move, I would say. It is a normal thing. But something that we need to keep in mind, I believe, is that the LLMs, they didn't reveal all their secrets yet. So we still have a lot to do when it comes to understanding to building models that are helping us in full capacity, I would say, when it comes to the intelligence. We are still far from achieving a full intelligence, I would say. Agents are there probably to automate more things, but they are coming also with their issues that we need to solve. And then at the end of the day, the foundation and the backbone for these agents lies actually under on the foundation models, or the quality of the foundation models that we are building. And one of the most important things that allows us to work with agents is the reasoning part, right? So we are working on improving the reasoning capabilities of these models. We should have few models that are coming soon that are more capable in reasoning. They are more capable in tool calling, and they are more capable in agentic kind of capabilities. The second thing that we are looking into is really pushing this architectural aspect in the large language models. We believe that, again, now that we have reached a certain stagnation in terms of data, everyone has consumed almost all the data that is publicly available there. The next move that we need to make is probably rethink completely the transformer path, I would say, and try to find a new architecture that are capable of training fast, using less infrastructure to train, and then using less infrastructure when it comes to the inference and to the consumption of this model. So this is what we are working on. I hope we can come back next year to show you more applications of these models. But one of the things also that on the application side is how to use these models to control the robotics. So the merge between AI and robotics is, in my opinion, the next move when it comes to the application side. And I hope next year I will come with a robot to just present with me. I am done. That's the last slide. Thank you very much. If you have any question, please feel free.